Thank you. All right, so as she introduced me, you might have noticed I have some relationship to NASA, and I do consider myself a rocket scientist. So I'm kind of uniquely positioned to catch all of the cringeworthy bits that come up in a movie like this. However, you're happy to hear that this is not actually that bad. So the science in Gravity is pretty good overall. Quran obviously did his homework or had other people do their homework and ended up with a really nice science story to this movie. But I will bring up some of the things that Gravity did not get so right, and then some of the things that it did get right. Okay, so let's start with the one big theme that goes through some of my first few points, which is space is huge, and it's, I mean, really huge, okay? So even at low Earth orbit, where most of this takes place in the movie, space is enormous. Now, it's true that we have a lot of stuff in orbit around Earth. So this is an artist's conception. Actually, these are all exaggerated, obviously. When you take a picture from, out in orbit, the Earth does not look like this. These are all exaggerations. But there still is a lot of stuff, satellites, debris, microsatellites, larger satellites around Earth. But it's still an amazing amount of space. So if these were all shrunk down to point sizes on here, you would see that really none of them are within sight line of each other. They're really far away in terms of actual distances, and it's an amazing amount of space out there. You think of the whole circumference and surface area of the Earth, and then magnify that a little bit out into space, and that's a huge amount of area. So this leads to the first few issues that I had in the plot points of Gravity. Number one, after the debris explosion, Clooney tells Bullock to set her watch for 90 minutes. And these might be some spoilers if you haven't seen the movie before, but just remember them and then they'll come back to you when you're watching the movie. So Clooney tells Bullock to get her a watch out and set her alarm for 90 minutes, okay? Because the debris that happens is gonna come right back around in 90 minutes. When he does this was already after a few minutes that they've heard news of the explosion. So a few minutes had passed and he said, set your watch for 90 minutes. So at the nominal ISS altitude of 400 kilometers, this is 400 kilometers above Earth's surface, of course, the orbital period is 92.5 minutes. Yet the debris actually comes around right when her alarm goes off. Her watch starts beeping, and then the debris starts flying right at her. So either he was extremely prescient, he knew exactly what the altitude was at that time and exactly what the orbital period was, and told her to set her watch for 90 minutes, or it was just a really good guess. Because in reality, the ISS, the International Space Station, actually changes height in time, right? It's not set at 400 kilometers. In fact, here's a plot from 2010, 2011, during which they did an orbital raising. So you're at this lower altitude for a while, and you can see that things start to decay. Every once in a while, they have to do a pretty severe orbital raising and get it back up to a higher altitude, and then over time, it will decay again, sometimes slowly, sometimes more quickly, depending on solar activity. So anywhere that you are on that graph, that changes your orbital period around the Earth. But somehow, right after 90 minutes, she set her alarm, the debris came right back around. So it was either just a really good guess or for dramatic effect of the movie. The other thing about the debris is that if you notice and pay attention to this during the movie, the debris is pictured as going from east to west in the movie. But almost all satellites actually orbit west to east. That east to west motion is called retrograde. It's very fuel expensive to get a satellite in that orbit, so almost all satellites are not in retrograde orbit. So they're actually going west to east, yet the debris is shown as east to west. Again, it makes for a better film, but probably not what would have happened if the Russians blew up one of their satellites. Okay. So still keeping in mind that everything's really far apart, space is really huge, the ISS and the Tiangong, the Chinese space station, are actually very, very far apart. So they're not that close together. So I would say it would actually be impossible to travel from one space station to the other in the way that you'll see happens in the movie. Their inclinations are different, although their altitude is pretty similar, but their inclinations are quite different, and I'll talk about what that means in a second. The even more severe error was that the ISS and Hubble are even farther apart. So at one point, when they drive from the Hubble to the ISS, that's not going to happen. So here's pictured is the Hubble is at a much higher altitude. You can see written here, my mouse works, yep, 560 kilometers altitude. for the Hubble Space Telescope, 417 to 420 during this time of the International Space Station, but their inclinations, so you can see this angle of the orbit with respect to the equator, are very, very different. Right? Hubble Space Telescope is about 29 degrees. ISS is always something around 52 degrees. And that inclination makes the biggest difference because it's really, really hard to change inclinations. Okay, it's hard to change altitude, but it's really, really hard to change inclinations. So that makes it almost impossible that they would be able to get from the Hubble Space Telescope to the ISS. Even if you kind of picture this as a distance on the Earth, you see how much of a distance that is, and that's not taking into account the altitude. So when Clooney kind of drives them in his MMU from the Hubble to the ISS, that's just bad science. That would never have happened. Okay, so changing altitude requires fuel, but changing inclination requires even more fuel, and there's no way his little jetpack had that amount of fuel. In fact, entire rockets calculate fuel down to small, small amounts to be able to do maneuvers like this, and they need entire rockets to do that. Okay, so the third thing here I want to talk about is this communications blackout. So at one point, they got word that there was a communications blackout, right? Communication satellite had gone down. There was no way they'd be able to talk to anyone. From there on out, it was Clooney and Bullock alone. They couldn't hear from anyone. As far away as the Hubble is from the ISS, all those communication satellites that you and I rely on for our cell phones and GPS, those are all much, much, much farther away. So this certainly does not make sense. Here's a picture of, this was actually from several years ago, so it's not even current, but this is a picture of all of our communication satellites in orbit around the Earth, and they travel in what's called geosynchronous orbit, and that's at about 6.6 Earth radii, or 35,000 kilometers above the surface. And the reason they like this orbit is because as they go around, they actually stay fixed with a geographic point on the Earth, because out here they travel at the same distance that the Earth rotates with time. So if you have one here pointing at North America, it's going to continue to point at North America even as that little Earth rotates around. So it's a really nice orbit to be in for communication satellites, for weather satellites, but that's nowhere near the space stations or the Hubble Space Telescope, which on this picture you couldn't even see the orbit. It would be so close to the Earth at that low Earth orbit. So how exactly would an explosion way down here at low Earth orbit create a communications blackout and take out all of these satellites? It wouldn't, right? Not possible. So that never happened. That was probably, for me, the biggest, when I was watching it, when they made that announcement that they had lost all communications, because that's just not possible. Now, if there were, say, an explosion of one of these guys out here, maybe several kickoff explosions as a chain reaction from that, that's a possibility. But anything happening down here at low Earth orbit would just have no effect on geosynchronous orbit. Okay, the last thing here I want to talk about that was pretty bad, and this might be open to interpretation. Clooney is a terrible astronaut. You may or may not like him as an actor, okay, but as an astronaut, he's just pretty bad. So one of the things he does in the film is you'll see is when Bullock's running out of oxygen, he keeps talking and talking to her, asking her questions, getting her to reply back to him, even when he says that she's running low on oxygen. So he tells her to save oxygen, but then keeps asking her questions that she has to tell him about. And that makes no sense at all. That's not something an astronaut would be trained to do or would do in a real life situation like this. I couldn't understand exactly what he was getting at with doing all of that, but that was not a smart move. Also, he's pretty reckless. There's a lot of things that go on that aren't quite believable that an astronaut would do, but he really didn't have to tell her to let go of him when they were tangled up in the parachute line, and you'll see this scene in the movie. It's a really beautiful scene and beautifully shot, but he kind of just tells her she has to let go of him, and whatever happens after that happens. But she doesn't have to let go of him, right? There's in space, she could have done a small pull, he could have been pulled in, grabbed a rope, anything like that. There was nothing stopping her from trying to get him closer to something that he could hold on to. There was nothing that meant she had to let go of him and let him tumble into free space. So all around, to his own detriment. He was a terrible astronaut. Okay, so I do want to highlight some of the science that's actually pretty good, because there were a lot of things in here that were pretty good. So the spacecraft, the outside and the interiors of the spacecraft are all very accurate. So I love these scenes where you can see all the dials and you can see all the handles in the spacecraft, the several different vehicles that they're in, and all of it's very accurate, even period specific to when these spacecraft were manufactured. This is supposed to be set in the future, and that might mean all these space stations are closer together, and that's why they were able to travel between them. But they're still using the current iterations of the interiors and exteriors of these spacecraft. So that was pretty cool to see. The second thing that they did right was actually highlight the problem of space debris, right? So this is very real. We potentially have a very big problem if we have multiple explosions that could cascade and create chain reactions in space. There's something called the Kessler Syndrome, which you can look up, named after a NASA scientist who kind of coined the term, meaning that things could explode in such a way that they could, explode other spacecraft nearby, cause debris from other spacecraft nearby to then kind of mushroom out and affect other spacecraft in nearby orbits. And that is a real fear. So we blow up spacecraft pretty regularly, so it hasn't really happened. It hasn't gotten to that point yet. But in the future, when we put more and more stuff up into space, it is likely that we could come to the point where a Kessler Syndrome type scenario is not too far off. So I liked that about this, that it actually put into the public's mind the idea of space debris and the dangers of that. And then the other thing that was really good was that the Chinese space station, Tiangong, was shown to burn up in the end. That was completely realistic. So the fact that it deorbited, ended up burning up in the atmosphere, turning into a fireball, that actually happens. Okay, so that was one thing that was absolutely accurate. So all space stations, like I showed that graph before of the ISS, have to periodically raise their orbits over time, or due to that atmosphere they're flying through, they will slowly go down and down until they burn up into the thicker atmosphere. So let's take a look at Tiangong, because actually Tiangong 1 did deorbit last year. Some of you may remember this from the media. The reentry happened in April of 2018, so just about a year ago. This is a plot showing its altitude in its years up into its final maneuver, which happened sometime in 2016. And after that, they just kind of let that orbit decay. You'll notice that once it gets to a certain point in the atmosphere, it really drops, right? It starts to just drop like a rock towards the Earth. Oops. So there you see it dropping, and then at some point, it does turn into a fireball and breaks apart, everything burns, and the rest that hasn't burned actually plummets to the Earth. Now, the Chinese tell us that this was planned, so as far as we know, this was a planned reentry. We didn't get a lot of advance warning, but they claim that they didn't lose control. It was just all planned. They wanted to decommission the spacecraft, and right now, the only way we have of decommissioning spacecraft is to just let it burn up in the atmosphere and get lost. So one of the interesting parts about this was that the reentry location was uncertain, but there was actually a predicted location here shown in green, with the highest probability being at the top of this green block and the bottom of this green block, so somewhere near 40 degrees latitude, north and south. And so Iowa City was actually a possibility for where this would land. Now, of course, most of it burns up and it becomes these fireballs that come through the atmosphere. This is actual footage of the Tiangong burning up in our atmosphere. But some small, softball-sized pieces of metal, maybe slightly larger, could actually survive that reentry and land somewhere on Earth. Now, anyone take a guess where it actually landed? Ocean, water, right. Very good. So, that's always the most likely place because most of the planet is water. So it landed somewhere over here in the middle of the ocean, very far away from any land or any human populations. So that was pretty good, even though Iowa City was on the list. Okay, so overall, Gravity really has more good science than bad, I would say. And it's a well-shot film and very nice to see. If you've seen some of these memes online, gravity actually wasn't the right name for it. Zero gravity would have been better, or angular momentum. Just don't add torque. Okay, enjoy the film.